Hello, this is Scott. Hopefully you've been following me on my YouTube channel. If not, welcome. And so I cover a variety of different topics in data science and analytics, and also commercial and open source platforms. Today we're talking about a commercial platform called Statistica, and we have a hands-on series going, and what we're going to talk about today is non-parametric statistics. In fact, this is very basic non-parametrics, descriptives, and some independent hypothesis testing. So the platform is Statistica, and I've been using this data set that's available inside of Statistica. And you can see me use this data set in previous videos. And what we want to do is we want to talk about why use non-parametrics and the platform, applying the platform to a couple of different columns in this data set. So very briefly, non-parametrics, we don't have to make any assumptions about the data itself. You can gain a lot of power in statistics if you can assume a parametric form, such as normality, but not every data set is normal. And in fact, this data set, if we were to go into descriptive statistics, as I've shown you before under basics, and we were to test whether these items were normally distributed, they would not be. So that is not necessarily a problem because we can run non-parametrics. Now, why should I not just always use non-parametrics? It's because if the assumptional forms can be adhered to, the power increases. In other words, the likelihood to make a correct decision on a data set is improved if you can make model assumptions like normality. It improves the power of the statistics, and you can do a lot of additional things. However, today we're talking about non-parametric. So where do I find non-parametrics in Statistica? Well, under the Statistics tab, if I go to non-parametrics, you'll see some of the basics. And this doesn't include every part of Statistica, but it covers some tests and things that are very useful. So let's do that. Let's go in here and create some description. So as I just told you, these three items are going to be, we know if we tested them, they would be not normal, and I can compute some descriptives of these. So let me just create a summary for those. And by the way, so a lot of parametric statistics use rank and order statistics. In other words, the relationship of every value to its constituents versus a mean. So all percentile based, in other words, would be a way to look at it. So here I have the three different test items, and I can look at, for example, the median, the 50th percentile for those. I can look at the difference in the minimum, the maximum. I can look at the difference of the 25th percentile, the 75th percentile. I can look at the interquartile range. I can look at the geometric mean, which actually is very useful in financial data, the geometric mean, where I'm looking at rates rather than the physical center of distribution. So that's one thing that we could do here. We can also look at graphics. So if I wanted to look at box and whisker, I can picture this median, lower quartile and upper quartile. So the 25th percentile is the lower quartile, and then the median, and then the 75th percentile, the upper quartile. And then the whiskers provide the range in these plots. And so I can see the different values for these 3 different test items. If you were with me before, what we're talking about is we're talking about the difference in testing prior to an intervention or post-intervention so lots of different things that you can do with describing the distribution, and hopefully you'll find that meaningful. The other thing that I can do is I can actually create, do statistical tests, hypothesis tests. So to get there, let me shut this down. And let me go back to the non-parametrics area. And let's suppose that we want to perform a statistical test on item 1 and whether there's a difference between male and females. So this is an independent test. In other words, like before when I was talking about repeated measures where it's on the same student, in other words, the student is going to be the observational unit, and I'm across time, and of course, the variation is within the student. You know, here I'm comparing the difference between it's independent in the fact that I'm comparing a group of males to females. So I'm going to compare 2 groups, and the variables itself, I'm going to select as a dependent variable this test item 1, and we will pick gender. Okay. So I'll click OK there, and let's perform a Mann-Whitney test. So I'll come down, and you can, by the way, I mean, there's multiple tests that you can perform, right? So I'm going to perform this Mann-Whitney test for simplicity and look at the value here. So what this measure, again, is the null, is that there is no difference between the male and female group. The means are the same between the 2. And testing at, say, an alpha of 0.05 or any reasonable alpha, I would fail to reject because the p-value here is 0.928, right? Or 0.929. So I would fail to reject, and there is no difference that can be assumed by these groups. And again, there's all kinds of different things that you can do within. You can create visuals. In fact, let's create one visual before we leave. We'll do a box and whisker, and we'll do test item 1 for male and female. And even visually, there's really not much difference, and that confirms with the power of statistics. I guess one parting thought is parametric statistics, when we can assume normality and other things, the computational power, the speed at which it's running an algorithm is much, much faster than converting everything to ranks. And that's one consideration, although it's less of a consideration today with all of the processing power that we have. But just something to note, especially in a very high dimensional space, non-parametric statistics can take a long time to run. So with that, I'll quit. We're going to talk about non-parametric, a couple of dependent sample tests that we can run next time. But again, I want to keep these short, so I'll see you on the sunny side.